Good morning. Today's March 27th. It's a Monday. Let's take a look at today's agenda. Notice that it is a teacher work day. All your work that's submitted by 11:59 will go into the report cards. So you notice it's asynchronous. We're going to be talking about introduction to systems, open, closed, and isolated. So you'll find the big blue button link here. And today's assignment here, Nearpod async systems, and then you'll have some system notes here. So you can also get to that through the module page. All right, and if you look at the module page, all right, you have your assignment lists here. So today's assignment is open versus closed versus isolated systems. We'll be talking about conservation of energy today and this week, and doing potential energy and kinetic energy calculations. Right, so here are your two assignments, the graded assignments for week 10. Right, here are the notes for conservation of energy. So if you click on this, you'll see an agenda and the notes that go along with this. So these are the things that you should be writing in your notes and making flashcards and submitting that to me on Offline Tracker. The difference between closed, isolated, and open systems. So here are your definitions. Right, and these at the end of this you will see, we'll be going over this, but these are your vocabulary. Right, so that is in your module page. On the notes page. All right, so let's get started here. All right, so your learning target today is I can define what energy is. We've been working that all this week, last week as well. I can define and give examples of kinetic and potential energy. So when you do this assignment, make sure that you read all the slides and do all the activities. There is an evaluation at the end. Conservation energy, I can explain how kinetic and potential energy can be transformed in a system, and I can apply the law of conservation of energy to the total energy of a system. So those are some of the calculations we'll be doing this week. System and conservation of energy. To understand how the system works, especially something complex, scientists need to be able to define what the limits or boundaries of what the things are. So let's take the human body as an example. It might seem like the skin is the obvious boundary between the person and their environment, but the answer may not be so simple. Air passes freely through the nose and the mouth. Some of it enters the bloodstream, but some of it does not. At what point does it become part of the body and stop being part of the atmosphere? So the concepts of systems. To deal with such issues, whether examining living beings, machines, or simple objects, scientists approach using concept of systems. So here are your key terms. A closed system is a system that allows energy, but not matter, to enter or leave. An isolated system, a system that allows neither energy nor matter to leave. An open system, a system that allows both energy and matter to enter or leave. And here's the definition for system. a set of interrelated parts that function together and can be studied as a unit. So these are your vocabulary. So you would want to write these down, keep these in your notes. You'll be doing activities in this Nearpod, so keep these handy. So let's take a look at this video on systems, open, closed, and isolated. There are 5 questions to answer, so please do so as a check.
Systems: open, closed, isolated. Systems are used to model the movement of matter and energy between substances. There are 3 types of systems: open system, closed system, and isolated system. In an open system, there are exchanges in matter and energy with the surrounding environment. Mass and temperature change. There's a transfer of matter and a transfer of energy in the form of heat. So as you can see, the before and after the mass is different, and that is because matter can leave the system. Heat can also leave the system. Matter can also enter the system, and heat can also enter the system.
All right, so we burned a candle in a dish. What type of system was that? An open system, a closed system, or an isolated system? So if you would answer that, if you need to, go back and listen to the video again so you can make the correct response.
In a closed system, there's exchanges with energy with the surrounding environment, but the matter does not leave. Mass does not change, only temperature. So there's no transfer of matter, but there is a transfer of energy in the form of heat. So as you can see here, the before mass and after mass are staying the same because matter stays in the system and cannot leave, and matter cannot enter the system either. But heat can enter and leave the system.
All right, when you put baking soda and vinegar in a beaker and cover it with a balloon, what type of system is it? Is it an open system that allows the um, matter to leave? Or is it a closed system that keeps all the matter inside? Or is it an isolated system which keeps energy, matter, and energy inside the system? Right? If you don't understand that, go back and rewatch that last section so you can answer correctly.
In an isolated system, there is no exchange of matter or energy with the surrounding environment. Mass and temperature do not change. A perfect isolated system, however, does not exist.
All right. How are isolated systems different from closed systems? Okay, one is isolated systems let heat and energy in or out. Closed systems don't let anything in and out, not even energy. Or closed systems let heat and energy in or out, but isolated systems don't let anything in or out, even not even energy.
There is no transfer of matter and there's no transfer of heat. So as you can see, the mass before and after stays the same, and that's again because matter cannot enter or leave the system, but heat can also not enter or leave the system. So in an open system, heat and matter can both enter and leave the system. In a closed system, heat can enter and leave the system, but matter cannot. Matter stays inside the system and matter cannot enter it. And in an isolated system, heat cannot enter or leave the system, and matter cannot enter or leave the system. So, can you tell me what type of system is this?
All right, is it an open system, closed system, or isolated system? Go back and take a look at the picture there to take a look at what that looks like. Remember, open systems let energy and matter in or out. Closed systems only let energy in or out. Isolated systems keep everything in, energy and matter.
This is a closed system. How about this?
All right, so it looks like it's open to the environment. So I would say this would be an open system because there was no top to it that would keep matter from leaving.
This is an open system. Thank you for watching another Adventures in iSTEM and Beyond video. Don't forget to subscribe and turn on notifications for more.
All right, so let's take a look at this example. Here is a drag and drop. All right, so here, system B, matter can enter or leave, and energy can enter or leave. So if you thought this was an open system, you would be correct. Here, system A, only energy can enter or leave. So that would be a closed system. We don't have a real good representation of what an isolated system. Isolated system does not let anything leave. All right, so let's take a look at the fill in the blanks here. A closed system is a system that allows energy, but not matter, to enter or leave. An isolated system is a system that allows neither energy nor matter to enter or leave. An open system is a system that allows both energy and matter to leave. And a system is a set of interrelated parts and functions together as we can be studied in a unit. So again, if you had taken notes from the key ideas, this would have helped you with the fill in the blank thing, fill in the blank activity. All right, so let's take in a system, we talk about energy, and then you can see here, according to the law of conservation of energy, the amount of energy in an isolated system neither increases or decreases. So we're talking about a system just so that we can take a look at how this would work. Now, isolated systems, remember, don't let anything in or out. So heat, energy does not stays in the system as well as the matter. So in an isolated system, increases nor decreases during the physical and chemical changes. Instead, the amount of energy stays the same. The energy can, however, change form. So here, if you take a look at this pendulum, we have gravitational potential energy according to its position. Because of the height, the maximum height here, it has no kinetic energy, so there's no movement. We're just holding it there in space. We let it go, and it changes from potential energy. So it loses potential energy according to its height, but it gains kinetic energy. So at the bottom of this swing, kinetic energy is the largest, so its speed is the largest. And then as it goes up, it loses kinetic energy, but then gains potential energy. So this is how we think of in an isolated system, how could conservation of energy can neither be created or destroyed, but can be transferred from one type of energy to another. The fact that energy is neither created nor destroyed may not be obvious from everyday experiences, since most of the system people experience in their daily lives, such as human body, a car, a house, are open systems. A car's fuel may be lost as the car drives, but just as the mass of the fuel is converted into exhausted fumes, fuel energy actually transforms and escapes into the surroundings. So, again, conservation of energy, if we look at this in an isolated system, kinetic energy is zero because it has all its potential, it's all potential energy. It's going to, when you let go of it, it'll swing and increase speed, which will make the kinetic energy go to the maximum at the bottom. Potential energy, because of its height, is at the bottom. It's going to be zero. As it starts to swing up, it starts to lose kinetic energy because the speed slows down, and then it gains potential energy from its height. Okay, so a closed system can make it easier to see the conservation of energy than an open system. Closed systems are generally artificial, designed with the goal of containing and preserving the content. So here's an example of a closed system. A bomb calorimeter is used to estimate the amount of energy in the food. A measure of amount of water is placed in the sealed insulated container, and sort of like a thermos. So we can measure the temperature change and this one will make it so we can measure that and then tell you how many calories in a food system. So this is an example of this closed system. All right, so we have some questions for you, 1 out of 4. Which type of system is this assumed to be totally unaffected by the outside influences? Is that an open system, a closed system, or an isolated system? If the energy can be neither created nor destroyed, what happens when the kind of energy appears to decrease? Right? So you're going to pick 2. Is it energy is transformed into a different type? B, energy moves out of the system. Or C, energy can not transform into another type. So pick 2 of those 3. All right, which of the systems is closed? So let's take a look at the picture here. Is it B, a closed system, or is it A closed system? Which of the systems is open? Is it B, where it looks like matter can go in the system or out of the system, energy can go in the system or out of the system? Or is it A, where only energy can go in or out of the system? All right, so this is your report. Grade yourself on your effort in this assignment, 5 to 10 points. Ask yourself these questions. Did you complete all of the assignment? Did you take notes? Take a screenshot and submit this. All right, thanks, ladies and gentlemen. I will talk to you on Tuesday. Have a good day.